Good morning, students. How are you all? Hope everyone are fine. Today, we are going to learn about kinematics, which is a branch of physics deals with one-dimensional motion of the objects. In that, rest and motion, a body is said to be at rest if it does not change its position with respect to its surroundings. If a body changes its position with respect to its surroundings, then the body is said to be in motion. Let us see an example. Suppose a book is lying on a table. The book is at rest with respect to the surroundings. But the earth is revolving round the sun. Therefore, anything lying on the surface of the earth is also in motion. We can thus conclude that the book is in motion with respect to the sun. Let us suppose a person is traveling in a train and he passes by another person standing alongside the track. The person standing along the track will see the person and everyone else in the train as being in motion. But all the persons sitting in the train will be stationary with respect to each other. So, from the above examples, we can understand that an object may be in motion with respect to another object, but may be stationary with respect to a third object. According to A, C is in motion, but in relation to B, C is stationary. Students, till now we studied about how can we decide the objects are under rest and motion. Now, if the objects are under rest, we are not going to discuss anything about it. If the objects are under motion, we are going to find out how the path of the objects is going to be changed. Let us look at motion and its types. Before entering into the topic, we will discuss some things like uniform and non-uniform motion, time, speed, etc. Let us see the learning objectives of the topic. By the end of this chapter, we will be able to learn about define the terms rest and motion, differentiate between slow and fast motion, explain the methods to measure time, measure the speed of an object, identify the units of time and speed, compare the speed of two objects. Let us start. Before entering into the topic, we should know that what we know exactly and what do you know exactly, and let us know. Okay, children, let's start. We know that generally we see many examples of motion around us like birds flying in air, buses, autos, cars, bikes, moving on roads, trains on railway tracks, etc. Similarly, the objects like trees, buildings, electric poles, etc. appear as if they are in motion when we observe them from a moving bus, whereas the same objects appear at rest when we observe them while walking. Am I right, children? Children, do you know? Let us answer the questions. How do we decide which object is moving and which one is at rest? Are these trees, buildings, electric poles, etc. really in motion or at rest? Let us know. To find out the answers to these questions, we need to understand the terms motion and rest. Isn't it, children? Otherwise, we are unable to decide what exactly whether the objects are moving or under rest. Let us go for the deep discussion about it. To answer these questions and all, let us observe the conversation between two boys standing beside the road.
Hey, I got a small doubt. What is the state of motion of the tree?
It is at rest.
What is the state of motion of the bicycle?
It is moving.
What is the state of motion of the boys on the bicycle?
They are also moving along with the bicycle.
How do we decide that the bicycle and the boys sitting on it are moving?
With respect to their surroundings, the position of the bicycle and the boys are changing with time. So, we can say that they are in motion.
Now, observe the conversation between the boys on the bicycle.
What is the state of motion of both those boys standing beside the road?
They are in motion.
What about the state of motion of the tree?
It is also in motion.
What is my state of motion then?
You are at rest.
What is the state of motion of the bicycle we are riding?
It is in motion.
From the discussions, a body may be at rest with respect to one set of surroundings and the same time be in motion with respect to another set of surroundings. Thus, motion is relative to the observer. Definition of motion. An object is said to be in motion if it changes its position with respect to its surroundings in a given time. Definition of rest. An object is said to be at rest if there is no change in its position with respect to its surroundings in a given time. Coming to uniform and non-uniform motion. For example, a moving vehicle, assume it's a car A, covers a distance of 150 meters in the first 10 seconds, 150 meters more in next 10 seconds, 150 meters in the third 10 seconds, and 150 meters in the next 10 seconds. In this case, the moving vehicle, that is car A, covers 150 meters in each case of 10 seconds. As the object covers equal distances in equal intervals of time, it is said to be in uniform motion. Similarly, a moving vehicle, assume it is a car B, covers a distance of 50 meters in the first 10 seconds, 90 meters more in the next 10 seconds, 180 meters in the third 10 seconds, and 230 meters in the fourth 10 seconds. In this case, the moving vehicle, that is car B, covers unequal distances in each 10 seconds as the object covers unequal distances in equal intervals of time. It is said to be in non-uniform motion. Let us see slow and fast motion. We observe many objects in motion in our daily life. In some cases, objects move slowly, and in other cases, they move fast. If vehicles are moving on the road in the same direction, we can easily tell which one of them is moving faster than the other, whereas in different directions we cannot decide easily. But we can decide whether the motion of an object is slow or fast based on the distance moved by the objects in a given interval of time. Thus, we can conclude that the distance traveled by an object in a given interval of time can help us to decide which one is faster and which one is slower. Therefore, an object that covers less distance in a given time is said to be in slow motion, whereas an object that covers more distance in a given time is said to be in fast motion.
Hi uncle, could you please tell me what the time is? I forgot to put on my watch today.
Hi, my dear child. Now the time is 8:20 a.m.
Oh, it's 8:20. I have to go to school quickly. I should reach the school on time. Hey, look, that bus is moving very fast. Why is this bus so slow?
Why are you so late today?
We use the word time for different purposes. In some situations, without using the word time, we express the duration of time like so late, so quickly, etc. Let us estimate the time now. Observe the condition here. Veena and Ranjit started for office at 9 a.m. from their houses, which are side by side. Vinay started on car and Ranjit on a bicycle. We can easily estimate that Vinay reaches the office earlier than Ranjit. But to answer the question of how early Vinay reached, we need to measure the time taken by both Vinay and Ranjit and find the difference of time between both the cases. For this, we need time measuring instruments like watches, clocks, etc. Because at present, time is measured by modern and advanced instruments like electronic clocks, digital clocks, quartz clocks, etc. A few decades ago, people used pendulum clocks that have now become rare. Measurement of time using stop clock. Stop clock, that is a stopwatch, is an improved form of a wristwatch and it can be used to measure the time interval between the occurrence of events accurately. It can be started and stopped by pressing a button and measures time up to 1/10 of a second. We might have seen stop clocks in the laboratory to measure the short intervals of time like time taken for completion of chemical reaction or time taken by the pendulum for one oscillation, etc. Similarly, stopwatches also help us to accurately measure the time in running races, swimming races, etc. Nowadays, stop clocks are found in almost all cell phones. Units of time. Based on the context, we can express the time in seconds or minutes or hours to specify the occurrence of time and the time taken by an event. The fundamental unit of time suggested by the International System of Units is the second. Its symbol is S. Larger units of time are minutes and hours. Like minutes and hours, week, fortnight, month, season, arm, the movement of the sun in the 6 months are also units for measuring time. Here is the following table gives us the information about the units of time. Now let us learn about speed. If a bus covers a distance of 40 kilometers in 1 hour, then its speed is 40 kilometers per hour. However, the bus seldom moves with a constant speed. Usually, it starts from rest, slowly picks up the speed, then for a short duration, it may travel with constant speed and stops. When speed is not constant, we express the speed of the object as average speed. Average speed is equals to total distance by total time taken. Thus, we can define speed of an object as the distance traveled by it in a unit of time. Usually, in vehicles, odometer shows the distance traveled in kilometers and the speedometer shows the speed of the journey in kilometers per hour. Units of speed. The distance covered by an object in unit time is called its speed. Objects are said to be in fast or slow motion depending upon the speed of their motion. The SI unit of time is second. Yes, and that for distance is meter m. So, the SI unit of speed is meter per second. Speed is also measured in kilometers per hour. We can convert kilometers per hour to meters per second. As shown on the screen, 1 kilometer per hour is equals to 100 meters per 3600 seconds. So by cancelling, we will get it is 5 meter per 18 seconds, that is 5 by 18 meter per second. Now coming to distance time graph. Generally, newspapers and magazines use different types of graphs to present the information in an interesting way. They often use bar graphs, pie charts, and the line graphs, which provide greater details of the information and make the information more interesting. For a body in motion, we can draw its distance time graph, which is a line graph. To draw the distance time graph, take a sheet of graph paper and draw two lines perpendicular to each other on it. Now mark the horizontal line as XOX dash. It is known as x-axis. Similarly, mark the vertical line YOY dash. It is called the y-axis. The point of intersection of XOX dash and YOY dash is known as the origin O. The two quantities between which the graph is drawn are shown along these two axes. Generally, the positive values are shown along OX on the x-axis and along OY on the y-axis. Let us draw the distance time graph of the data given in the table for the motion of a car. Decide the quantity to be shown along the x-axis and that to be shown along the y-axis. In this case, we take the time along the x-axis and the distance along the y-axis. Choose the scale to represent the distance and another to represent the time on the graph. For the motion of the car, scale could be x-axis 1 centimeter is equals to 1 second and y-axis 1 centimeter is equals to 5 meters. Mark values for the time and the distance on the respective columns. From the table, the set of values for time and distance are 0, 0, 1, 5, 2, 10, 3, 15, 4, 20, 5, 25, 6, 30, and 7, 35. The first number of the set represents time and the second number represents the corresponding distance. To mark for the set of values 0, 0, look at 0 on the x-axis and 0 on the y-axis. This point is the origin. To mark a point for the set of values 1, 5, look for 1 on the x-axis and draw a line parallel to y-axis passing through this point. Look for 5 on the y-axis and draw a line parallel to x-axis passing through this point. The point of intersection gives the point that represents 1, 5. In the same way, mark the points corresponding to different sets of values as shown in the image. Join all the points on the graph. It is a straight line, which is the distance time graph for the motion of the car. If the distance time graph is a straight line, it indicates that the object is moving with a constant speed, that is uniform motion. However, if the speed of the object keeps changing, the graph can be of any shape, that is non-uniform motion. So, we can say that the distance time graph indicates the type of motion, whether it is uniform motion or non-uniform motion. Hence, we can conclude that the distance time graph gives information about the distance covered by an object in a definite time intervals, and also the distance covered by an object at any instant of time is to be measured. Travel on a motor vehicle with your father to market or any place and observe the changes in the speedometer reading. Note the exact time when you started from home and observe the readings of the speedometer for every 10 minutes. This is an activity for you children. Try to do it and then let us clarify the doubts.